Time for one of my favorite data sets. We're just going to use it briefly here, probably revisit it again later. It's an exoplanet data set. So if you go to the GitHub Pack Publishing, hands-on gradient boosting with XGBoost and scikit-learn website, and you scroll down to chapter 5, actually it's chapter 4, you'll see this exoplanets.csv file. Click on that, okay? And click on View Raw. It's taking a moment, like it's a big one. And here we go. So this is an exoplanet data set. Go ahead and hit Command C and put it in. So we're going to do a new URL here. So load new data. I'm just going to call it DF again and not go back to the other one. I do that because I forget. I'm so accustomed to writing DF that if I call something else like DF exoplanets, I'll forget and start using DF and use the old data. And this will be a fun one to look at. We haven't looked at it yet in this class. So go ahead and load it in there. It's a CSV file and check it out. And say what it is, load new exoplanet data. Exoplanets, right? So you've got, note that's taking a moment to read it in. You've got different exoplanets in the universe. An exoplanet means that it's a planet that's not orbiting our sun. And finding exoplanets is a big deal in the world, you can imagine, right? I mean, it's tough to do because when you look into the universe, you know, the stars are kind of small, but planets are much smaller. So you actually can't observe them, as they say, from the naked eye or from like standard observational techniques. I think like one or two in history may have actually been, you know, visibly seen in telescopes or somehow, but usually that's not how it's done. Okay, usually what's done is the exoplanets are detected using, say, a technique like light fluctuation of a star. So if you look at a star's brightness and then you see that the star becomes dimmer periodically, what does that mean? Well, it means most likely that something is blocking the light, and therefore if something's periodically blocking the light, it's moving periodically in front of the star, and by definition, that's a planet. So that's what this label does. I have this label there, that's a column called label, that's what this data set does. These columns are light flux, so it's a measure of light. And the labels are 2 and 1, should be 1 and 0, it's better for machine learning. And label of 2 means yes, it's an exoplanet. The label of 1 means no, it is not. And if you check the number of, like what we need to check the size of this thing, right? It only says 3,198 columns, so what's the deal? Well, actually, that's a lot of columns, right? It's 5,000 by 3,000, right? So, and what is that? The other thing is like, you know, you can use code to figure that out, right? So multiply them together. It's df shape, the first element, times df shape, the second element, okay? Index of 0 and 1. And if you run that, this is, and if you comment out your 3, 16 million entries. Okay, so, you know, that's significant, 16 million entries. What did we have before? See, before we had 30,000 rows, and it's actually times 100, so it's 3 million. So it's actually not small, but the exoplanet data set, I guess, one of the issues, in addition to it's 5 times as big, it has 3,000 columns. And models are often built like sorting out the columns. So there's a lot more to sort, so it's going to take the models longer to build. Well, let's find out. Okay. Now here's the thing. We also need to redefine x and y because, right, when we defined our function, x and y were defined before. And, you know, you could modify the function to work with any data set, which would be kind of cool. But in our case, let's go ahead and copy in this code and modify it. Okay, it's the splitting the data into x and y. So I go down here to my new coding cell, and note that in this case, it's actually the target column is the first column. It is not the last, which actually is indexed with 0, right? So this would be all rows, but you want the 0th column. And here you want to exclude the 0. So what you would write there is you start on the first column, okay? That means you're including the first, and you go all the way. Okay, and if you're always unsure, you could check it. Like even for me, right? It's a little bit, it's not the last one, so maybe we should check it. Okay, let's run a little check here. So check that out, run that data, and I can just look at I can look at the first 5 rows of Y. They're all 2s, that's expected. And then the first 5 rows of X. And this looks good because it's got flux.1. I believe that is the first column. Great. And one other thing you may wonder, is this just a bunch of exoplanets? This is a topic we'll focus on later. If you want to see what is it, y.value counts? No, it's actually only 37 exoplanets, 5,000 are not. And we're going to focus on that piece of it, in a different lecture. So, because it's imbalanced, that's why. And that's a big issue in big data. All right, so what we want to do is actually time it, okay? We split it properly, so now we can, in fact, run our function using these different models. Now, let's start with the random forest and see how it does, okay? And again, this might take some time, all right? Hopefully not too long. Let's just run it, okay? And I do want to do all 3, so what the heck? Let's put all 3 in, and then maybe I'll pause the video. I don't really need to. Actually, that was fast. Wow. And again, that's the advantage of a random forest, because a random forest, it does not rely on. You don't have to wait for the previous model to build. Okay. Let's check the gradient boosting classifier. And then we'll do the XGB classifier. So these models are different, right? You've got to wait for each tree to be built before you can build the next one, right? And it's going to matter. And in case you're wondering, definitely different things are going to go into effect with the times. I can tell you that one of them is going to be your machine. Although really it shouldn't use, look, okay, I say that, but here you're using actually Colab's internet. So that's going to make a difference. And there are things you can do with Colab to actually access faster build times, which I probably should have looked at before doing this. I wonder if it would switch mid-build. I don't want to switch anything though, because I want to have a fair basis of comparison. And one other thing I'll comment on, I guess, before pausing is that the random forest classifier, note that the accuracy score is 99.2%, right? So that's pretty awesome. However, the data is imbalanced. So again, I'll leave it to you for now to try to think about why it's possible that a high accuracy score doesn't necessarily imply a strong model for imbalanced data.